okay, so again, the big issue here is that you cannot just be randomly guessing, well, I think the function should be x squared or the function should be x cubed. We need some sort of integral rule for this. And so that's what we're going to see on page 26 is we're going to be talking about the integral rules or antiderivative rules that you would have associated with finding the antiderivative. Okay, now before we do anything, I want us to talk about one key thing. So just watch this. Do not worry about frantically writing it down. If you are differentiating like 3x squared, we all remember like we drop down the 2 and we say that that's 6x. If you are differentiating 3x, then that goes to 3. If you are differentiating 3, then that drops to 0. So I want you to think about when you are taking the derivative, you are dropping terms. So you're dropping this exponent down, you're dropping the x, you're dropping the constant to 0. So when we're talking about a derivative, we want to think about it as we are dropping terms. Okay? Now, with an antiderivative, we are trying to go backwards. And so if we are trying to go backwards, the opposite of dropping would be that we are going to be adding terms. So an antiderivative, we are going to be adding terms. Okay, so keep that at the very front of your mind that with these integrals, antiderivatives, you're going to be adding things. Derivatives, you're going to be dropping things. Now, the first two properties here are just kind of as you intuitively would kind of think it happens. So the constant multiple tags along with differentiation. Constant multiple is going to tag along with integration as well. And what that basically means for the integral is that you can pull out the constant in front of the integral. Okay, so you can pull out the constant. All right, and then the same thing goes that for differentiation, we can integrate term by term or differentiate term by term. So that is kind of intuitive, the situation of the constant tags along and then the differentiate or integrate term by term. Okay, now when you are looking at our first big derivative rule, we have that the derivative of 3x is equal to 3. That's this kx, the derivative will go to k. Okay, now you guys, here's the deal. We are trying to go backwards. So what's going to happen is we are going to start with the integral of 3 and we're going to integrate 3 dx, and that has to take us back to the original function of 3x. So the integral of 3 dx will be equal to 3x plus c. And that's what I mean by with antiderivatives, you are going to add to it. So this integral of 3 is going to be added to get 3x. Okay, so again, when you look at this integral of a constant down below here, I have the integral of 5 dx. That's a constant. So what we're going to do is we're going to add to that, and that's going to give us 5x. Now, do note that you lose the integral dx when you use that integral rule. So what will happen is when I add the 5x, I'm going to lose the integral sign in the dx, and then I gain this plus c. And remember, the plus c is coming from the fact that there are no bounds. So we're going to add a plus c. Okay, now that constant that we add, it was x, and that was driven because of this differential. So this differential was x, so we added an x. So if we change the differential to theta, then we're going to be adding a theta. So it's going to become 5 theta plus c. Okay, so that is our first big integral rule, is the idea of if you have a constant, you're going to be adding an x or adding that variable. Okay. All right, so that's our first rule. Integral of a constant is going to be constant times that variable of integration. Now, our next big rule that we're going to use over and over again is going to be our power rule. So our power rule, again, was like if you had x cubed, you drop it down, subtract 1. Now, with antiderivatives, we're trying to go backwards. So we're going to have to start with the last step and go backwards from that last step. So instead of subtracting 1, we have to do the opposite of that, and that would mean that we add 1 to the exponent. Okay, so the opposite of the subtract 1 will be add 1 to the exponent. Now before we multiplied by the exponent. That was the whole drop it down. That changed into multiplication. Now what we're going to have to do is divide by the exponent. Okay, so we add 1 to the exponent and then divide by the exponent. And again, when we do this process, this is our power rule for integrals, but this process is going to be losing the integral and the dx. So below here, where I have x to the fifth, what I would do is I would add 1 to the exponent, so the x to the fifth would become x to the sixth, and then I divide by the new exponent. And I see that my integral sign had no bounds, so I add a plus c. So that is our power rule for the integral of x to the fifth, and we can always double check that using our antiderivative capital F prime equals little f, but really we just need our power rule to determine that. Okay, so this page is super important. Again, two big takeaways: derivatives you're dropping, antiderivatives you're adding, and then if you have the integral of a constant, it is going to be a constant times that variable, and then our power rule is that you add 1 to the exponent and divide by the new exponent.